Artificial cognition is qualitatively different from human cognition. Indeed, AIs rely on cognitive processes of their own to form unique categories of thought. By what means do artificial neural networks combine their categories of thought to construct their own semantic world? To answer this question, we introduce a fundamental cognitive property of synthetic cognition, categorical cutout. Categorical cutout refers to the process by which a neuron in layer n+1 extracts a specific semantic aspect, a categorical subdimension, from a broader category of thought carried by a neuron in the preceding layer n to which it is strongly connected. This extracted subdimension, along with others, contributes to the formation of a new, more refined category of thought detected by the layer n+1 neuron. For example, from the broad thought category, animals, carried by a precursor neuron in layer n, a neuron in layer n+1 might isolate the subdimension domestic animals, including tokens such as dog and cat, clearly separating it from other subdimensions like wild animals or humans. This kind of focused semantic extraction is what we call categorical cutout, and it exhibits 5 defining properties. Categorical reduction is the cognitive process by which the tokens making up a subdimension extracted from a broader category display stronger semantic coherence among themselves than with the entire set of tokens in the original category. For instance, an initial thought category in layer n might include diverse tokens such as glasses, kiwi, and car, which are semantically unrelated. By extracting the subdimension rough, round fruits, a neuron in layer n+1 isolates only the tokens orange, coconut, and kiwi, which are much more semantically aligned. Categorical selectivity is a corollary of categorical reduction. It describes the fact that an extracted subdimension includes a much smaller and more selective set of tokens compared to the full breadth of the original thought category in layer n. For example, starting from a pool of 500 tokens associated with the category animals in layer n, only about 50 might belong to the subdimension birds, outlined by the neuron in layer n+1. This neuron retains only the most relevant tokens for the new category of thought it constructs, reflecting a highly targeted and selective extraction. Separation of initial embedding dimensions refers to how an outlined subdimension, extracted by a neuron in layer n+1 from a thought category in layer n, becomes preferentially tied to specific dimensions of the original embedding space, which correspond to basic thought categories at the input of an artificial neural network. This separation illustrates how, during categorical cutout, a new form, a semantic subdimension, is carved out from the original category, while other aspects, the background, remain unextracted. For example, the extracted subdimension realistic quest action films may align with initial embedding dimensions such as action, realistic, and quest, but not with unrelated ones like drama, animation, or friendship, which remain in the background of the original category. The segmentation of categorical zones captures how, during the process of categorical outlining, an outlined categorical subdimension, that is, an extracted categorical form, from a thought category in a neuron of layer n becomes localized around a relatively precise semantic center of gravity, meaning it lies at a certain distance from that of the non-extracted categorical background within the space of the initial embedding dimensions. For instance, tokens like eagle, sparrow, and parrot, drawn from the animals category in layer n, cluster in a semantically coherent zone linked to birds. This zone is separate from that of other tokens like lion, dog, or elephant, which remain in the broader category and were not part of the cutout. Activational dispersion refers to the cognitive process whereby the tokens forming an extracted categorical subdimension do not share a uniform range of activation values. Instead, They are spread across a spectrum of activation intensities, both in the source neuron and the neuron performing the cutout. In other words, an extracted subdimension does not correspond to a neat, homogeneous block of neuronal activation values. For example, within the outlined subdimension birds, the token eagle may trigger a high activation, sparrow, a moderate one, and ostrich, a weak one, despite all being semantically grouped within the same extracted category. Thank you for joining us on this exploration of synthetic thought in artificial intelligence. To explore the three mathematical cognitive factors that make up the aggregation function and their role in how AI builds its own semantic world, you can watch the second part of this video on our Neocognition Lab channel. The article mentioned in the video, along with all of Neocognition's research, can be found at neocognition.org.